Good morning everyone. I'm going to explain the MATLAB code for Hamming code. So Hamming code is an error correction system that can detect and correct errors when data is stored or transmitted. It requires adding additional parity bits with the data. So Hamming code is a block parity mechanism. Data is divided into blocks and parity is added to each block. So standard Hamming code can only detect and correct a single bit error. So suppose the block code is represented as n, k. So k represent, I'll show you the block diagram. This is the communication system with error control coding. So Hamming code is an error control coding. It will detect and correct a single bit error. So you can observe here the message signal blocks of k message bits are given as an input to the channel encoder, and the channel encoder will make some arrangement so that the total number of bits will be different than the given input bit. So k is the number of message bits, but n minus k, which is called it as a check bits or parity bits, added to the message bit so that it will make a n bit code words in a channel encoder. So that will be n is the total number of bits in a block that will be generated by adding n minus k check bits to the given input message k bits. So that value n bit data is transmitted to the receiver through modulator and noisy channel. So after it passes through this noisy channel, at the receiving side it may contain noises, so that must be detected, that wherever the error present in the received data must be detected and should be corrected at the receiver side using channel decoder. Okay, so let us see what is the procedure used in Hamming code. So let us take one example. Here 7, 4 is a linear block code and the parity matrix is given in the example itself. So 7 represent total number of block code, number of bits in a block code after generated from the channel encoder, and 4 represent number of message bits. So what is the check bit? 7 minus 4, it is a 3 the parity check bits added to the input to 4 bit as a message signal. So 7 is an total bits in a block. So we need to check, we need to generate the code words from the channel encoder. After that we need to check what is a received vector. Then we need to detect and correct the received, any error present in the received data that must be detected and later it should be corrected. Okay, so this is the procedure we need to follow, and this is the code we have written in a MATLAB for same example. N is equal to 7, it is a code word bits per block, k is equal to 4 message bits. So A, it is a parity submatrix. So parity matrix should be taken initially to represent, or we need to calculate the Hamming code. So 111, 110, 101, 011, it is an parity matrix. So parity matrix is given like this: 111, 110, 101, 011. Okay, then G, which is a generator matrix. So I am explaining what is the procedure in the Hamming code. So the first initial step I will explain using this example. The first step, we need to generate the generator matrix. To get the code vectors, see what is the formula? D into G. So it is a matrix multiplication of received input message bit with the generator matrix. So how to calculate generator matrix? Generator matrix is calculated by taking the parity matrix along with the unity identity matrix. Unity matrix or identity matrix. Okay, so this unity matrix IK, what is the size? IK. So 4 cross 4 matrix. So K means message bit, it is 4. So IK means we need to write unity matrix, unity identity matrix by writing 1 in a diagonal manner. And P already it has given in the problem, so this we need to write. So this is the total matrix, we call it as a generator matrix. The next step, we need to find out the code vector from the channel encoder. Code vector can be found as C is equal to D into G, matrix multiplication. So matrix multiplication here, the code vector bits in terms of message bits are found using D into G. So D, the 4 bits are taken because input to message bit is in 4 bit in size, D1, D2, D3, D4, and G represent the whatever we have written IK into P. So this is a generator matrix. It must be multiplied. Okay. Also we can say modulo to addition, or we are multiplying the matrix row into column wise. So what is the answer? D1 into 1, then rest all 0. So D1, comma, D2, comma, D3, comma, D4, comma, then here D1 plus D2 plus D3. Next D1 plus D2 plus D4 and D1 plus D3 plus D4. So this is the way we need to multiply the two vectors, so two matrix. And for example, D, because D is an input message bit. So K, how much we have taken? K is equal to 4. So 4 bits must be taken. You can take any bit from starting from the 0, 0, 0 to 1, 1, 1, 1. So what I have taken here, 1, 1, 0, 1 is the message bit, 4 bits in a message vector. So it must be multiplied, 1, 1, 0, 1 message bit is multiplied with the G generator matrix. So if you multiply this way, you will be getting 1, 1, 0, 1, 0, 1, 0 for this message bit. So what is this? See, it is an code vector generated from the channel encoder, input channel encoder. So this is the channel encoder will generate the output. What is the total size? It is K into K and N minus K. Check bits are added so that N is the number. So here we have taken 7, 4 means N is 7. 4 is message bit. So how total 7 bits is generated from the channel encoder. Similarly, if you take this value, this is the answer. So 0, 0, 0 answer is 0, 0, 0, 0, 1 answer is this one. So same way C is equal to D into G, we will be getting the code vectors in this second column for all the message bits starting from 0, 0, 0 to 1, 1, 1, 1. Okay. So once the code vector is generated, it must be transmitted through the channel, and we need to check what is the received vector and whether any error is present. We need to detect and we need to correct it. So next procedure, the syndrome calculation. So let the received vector be represented in general R1, R2, R3, R4, R5, R6, R7, because the total block quote size is N. N is equal to 7. Same bit must be received at the receiver side. Now what we need to do? We need to detect the error, then correct the error. So the first step, at the receiver side, the syndrome will be calculated. What is the procedure for the syndrome? Syndrome is equal to received data multiplied by H transpose. What is H? H we call it as a parity check matrix. How to calculate H? H is calculated by taking the transpose of parity matrix P transpose into and with the I n minus k, n 7, k 4, so I is equal to 3. P transpose, what is P? P is this one, P is this one, it must be transpose. We need to take the transpose of P. So row will become column, column will become row. So P will become this way. So row will become column 1 1 1 1 1 0 1 0 1 0 1 1, and it should be written along with the identity matrix, unit identity matrix, with the size 3 cross 3. So this is represents the parity check matrix. How to calculate syndrome? H transpose. We need to write the H in transpose manner. So H transpose, the same H is written in the transpose. We need to take the transpose of H multiplied with R, received data. So what is the procedure? Again, row into column. So R1 plus R2 plus R3 plus R5. So row multiplied with column, so that it will generate the syndrome. So let us take one example. R received data is this value, 7-bit data, multiplied with H transpose. So H transpose already we have written. What is H transpose? The H is this one, transpose means row is become column. Row has become column. See, for this example, if you multiplied with the matrix multiplication with the R received data with the H transpose, this is the answer. We will get 1 1 0. So this syndrome is located in the second row of H transpose. We need to check the syndrome value must be checked in the H transpose matrix. So that value, calculated value, must come in any one row of the H transpose. That, see, 1 1 0 comes at the second row of the H transpose. What it represents? Hence the second bit counting from left to is in error. So corresponding error vector is then given by 0 1 0 0 0 0. So second bit is in error because we are getting the syndrome value which comes in the second row of matrix. So corrected code vector, which is the transmitted vector, is given by RA plus EA. So RA is the received data. This is the received data, should be added with the error vector so that corrected value will be obtained. This is the procedure we need to follow for executing the Hamming code. Same procedure we have written in the MATLAB code. So n is equal to 7, k is equal to 4, k represent message bit, a represent parity matrix, then g represent generator matrix. How to calculate generator matrix? The parity matrix and I of k. I of k means it is a unity identity matrix. Unity matrix is written, I of k is written in this way. Then what we need to check here, the parity check matrix also written initially. What is that? Parity matrix, parity submatrix transpose of P with I n minus k. So that parity check matrix also calculated. So this is the message bit. We have taken 1 1 1 0. Code vector will be generated by C is equal to G into P, right? Code vector is generated by P into G. So what is the procedure? So modulus addition, modulo 2 addition or matrix multiplication we can calculate it by writing modulo 2 addition with message and generator matrix. So C is equal to D into G. What is D? D is message. So message bit is 1 1 1 0. So that will be multiplied with G so that code vector is generated in the channel encoder. Now channel error, add one error to code. So I will add one error at second bit, code 2. The obtained code is 7-bit in size. So second bit I will make it into, suppose if it is 1, I will change it to 0 or 0. So it is an inverted code of 2. I will introduce an error at the second bit. Okay, so received is equal to code. Whatever the received bit, that code word with error will be received data. So what it does at the decoder side? So first step, syndrome will be calculated. What is the procedure? S is equal to, you can see here, what is the syndrome calculation? R into H transpose. So same thing we have written, syndrome is equal to H transpose multiplied with received data with error, but it is multiplication is written in terms of modulo to addition. So now we need to find the position of the error in code word. So this is the code we have taken as a index. Find is equal to 0. Initially this variable has taken as 0. For II is equal to 1:n. II means it is an index value for finding the error, n bit long. If find is not equal to 0, it is 1. Then error vector is equal to zeros of 1 comma n. Error vector initially taken as zeros. How many zeros? 7 zeros, because n size is 7. Error vector II is equal to 1. Suppose this index, error vector of II index is equal to 1. Search modulo error vector with H transpose. Search means, so it will calculate like a syndrome, or the variable has taken as search, and it will, how it will search? The received vector, error vector, all are zeros, and if it is index is 1, so it will search error vector is multiplied with the H transpose. If the search value is equal to syndrome, the find is equal to 1 and index is equal to I. Which position it has got error, that will be indicated by this program. Later, position of the error in the code word is obtained. Later, it will be added with the received data. Received data is added to the whatever the received the syndrome value, and corrected code is calculated as what I explained in the theory part. So let us take the whatever the value, the syndrome value. See, you can observe here the parity matrix, n is equal to 7, k is equal to 4, g is calculated by, because parity matrix already we have taken, that parity matrix is written along with I of k, so that g is calculated. Then H transpose is calculated by taking the parity matrix transpose and I of n minus k. Later message is taken as 1110. What is the corresponding code vector? 1110 with the 100. So you can observe in this table also, value is, what is a 1110, 1110, it is answer is 1110100. Same value you got here, code vector. So received data, what we have done, second bit we have changed, so that instead of 1 it has changed to 0. Then syndrome is calculated by using, what is the procedure? Syndrome is calculated by the received vector multiplied by H transpose, so that the syndrome is 1110. So 1110, it is H transpose, it is in the second bit, second row represent 110 means 1110 means it is a 110 means it is a second row of H transpose. That means there is a second bit, position of the error in code word is 2. So corrected code vector, it is added with that value, and we have got the corrected code vector. Okay, and message decoding is similar to the input message data. So this is about the Hamming code calculation. Thank you.